Hello everyone. Today we'll continue talking about rational functions, looking specifically at their graphs. Here's the text that we're looking at. The student is expected to determine and analyze the key features of different kinds of functions. In our case, we're going to look at the asymptotes of rational functions. Here are our learning objectives. The learner will be able to identify the asymptotes of rational functions using their graphs. And after doing more practice problems together in class, you will be able to find the vertical asymptote of rational functions. What is a rational function? A rational function is an algebraic fraction such that both the numerator and the denominator are polynomials. What this means is that at least the denominator of our fraction has to contain a variable. So for example, we have x squared minus 2x plus 3 over x minus 3. We have an x in the denominator. The next one we have is 4 over x. As long as we have a variable in the denominator, that is considered a rational function. And then lastly, 2x over x plus 4. So here are some graphs of rational functions, and it seems like they're always approaching a line but never touch it or cross it. So let's take a closer look. In this graph right here, our curves approaches the line y equals 3 and x equals negative 2, but they don't touch or cross these lines. These lines are called the asymptotes. So let's define the asymptotes. An asymptote of a curve is a line such that the distance between the curve and the line approaches 0 as the function approaches infinity. In other words, it is a line that the graph approaches but never touches. There are three types of asymptotes. We have slant asymptotes, horizontal asymptotes, and vertical asymptotes. Let's look at the first graph here. We have a horizontal asymptote, which is the dotted green line of y equals 3, and we have a vertical asymptote at x equals negative 2. In the second graph, we also have a vertical asymptote, and it is at x equals to 1, and then we have a slant asymptote at y equals 3x plus 1. In our video today, we will only look at vertical asymptote, and we will look at the other two types of asymptotes next time in class. So the vertical asymptote happens when the function is undefined, meaning the denominator is equals to 0. So to find it, we're going to set the denominator equals to 0, and so for x. We are going to use this graphic organizer to help you distinguish the three types of asymptotes, and we are going to fill out the rest of the graphic organizer in class when we talk about horizontal and slant asymptotes. So let's look at some examples together. The first example we have is x squared minus 2x plus 3 over x plus 2. So to find the vertical asymptotes, usually we say VA. You're just gonna set the denominator equals to 0. So when x plus 2 is 0, we're just gonna solve for x. So for x, and to isolate x, we're gonna subtract 2 on both sides. Plus 2 and negative 2 cancel out. We're gonna have x equals to negative 2. So the vertical asymptote for this function right here is just x equals to negative 2. Okay, let's look at another example. We have x plus 2 over x squared minus 9. So again, to find the vertical asymptote, we're just gonna set the denominator equals to 0. So we're gonna say x squared minus 9 is equal to 0. Remember, this is our difference of squares. So it is equals to x minus 3 and x plus 3. And then on the other side, we still have equals to 0. When you have two factors multiplied together and the product is a 0, either one of the factor has to be 0. So we're gonna say that x minus 3 has to be 0, or x plus 3 has to be 0. To isolate x, we're gonna add 3 on both sides. So x is 3, or we have to subtract 3 on both sides, and we have x equals to negative 3. So the vertical asymptote is x equals to plus or minus 3. I'll quickly show you how to graph this on your calculator. We are going to go to y equals and type in our function. Remember to put parentheses around your numerator and denominator. So we are going to say x plus 2 divided by x squared minus 9. And then you're going to hit graph. So as you can see right here, we're saying that the vertical asymptote is at x minus 3 and x plus 3. So you can see that there are two vertical lines right here that the graph approaches, but it doesn't touch across the line. Now let's look at another example. We have x minus 2 over x squared minus 4. Again, to find the vertical asymptote, we're going to set the denominator equals to 0. So we have x squared minus 4 equals to 0. And remember, this is the difference of squares. So we're going to have x minus 2 and x plus 2 equals to 0. One thing to notice in this problem is that after you factor out the denominator, you can see that the numerator actually have the same factor like the denominator. So I can rewrite this function like this. So in this case, I can actually cancel out the numerator and one factor of the denominator. This is a special case of discontinuity that results in a hole, and the hole is actually at x equals to 2. So instead of this being a vertical asymptote, it is actually a hole because this is a factor that you can cancel in both the numerator and the denominator. So after this, we are left with only x plus 2 being your denominator. So now we are going to set that equals to 0. X plus 2 equals to 0. So x is just negative 2. This is your vertical asymptote. So in this scenario, even though you have two factors in the bottom, one of it cancels with the one on top, which results in a hole at x equals to 2. The other one results in a vertical asymptote at x equals to negative 2. So when you graph this, we're going to y equals, type in the function, and as you can see here, instead of having two asymptotes like the one we have last time, we're only having one at x equals negative 2, which is what we found right here. And the other one, x plus 2, we actually have a hole. It doesn't show right here, but if you go to second trace and do value at x equals 2, y doesn't show anything because there is a hole in there. So what you learned in this video is that there are three types of asymptotes. You've learned that to find a vertical asymptote of a rational function, you need to set the denominator equals to 0 and so for x. We're going to learn about the horizontal and slant asymptotes next time in class and fill out the graphic organizer together. Before you come to class the next time, make sure you finish your entry ticket, which asks you to find the vertical asymptotes of two rational functions. And I'll see you then. Bye bye.